Hi, welcome to Jay's Journal. This is a pretty cool little thing, isn't it? It's a little bit unsettling. Which way is it going? It reminds me of that silhouette illusion that's been so popular on the internet the last couple of years. You know, the dancer, she's like this, and she rotates, but it's hard to tell which way she's rotating, and it's been labeled as a test for right brain, left brain. Which side of your brain do you use the most? Because, supposedly, if you see her rotating clockwise, you're using the right side of your brain. You tend to do that in life. If you see her rotating counterclockwise, that's the way you think she's going, you tend to be a left brain person. And this all goes back decades to this whole idea of some people, like artists, tend to use their right brain. Some people, like scientists, tend to use their left brain. Well, there have been some developments in this area. Nick Troya of the Biomotion Lab at Queen's University in Kingston, Ontario, has shown the silhouette illusion or confusion has really nothing to do with which side of the brain you're using, but it has everything to do with your angle of view. So for instance, if you're looking at it and it looks like it was shot from above, you'll get one impression of which way it's turning. But if it looks like it was shot from below looking up, you'll get a completely different impression. So for instance, let's look at his complete illusion now. There's the silhouette in the middle, but the full figured form on the left is shot as if you're about 10 degrees above it. And you can see most of the time, 60% of the time, it looks like it's turning clockwise. But on the other side, you've got a figure that's shot as if we were 10 degrees below it, looking up. It looks like it's turning counterclockwise. It has all to do with the angle of regard. Now, what I'm not saying is this, that if you're watching the silhouette on TV, you lie down on the floor and look up at your TV, it's going to work. Nor does it work differently if you get on a chair and look down on it. It all has to do with how it was recorded, not how you're looking at it. But that is the secret to the silhouette illusion. So you know what this all means to me? It's just another nail in the coffin of that old idea that either you're a right brain or a left-brained person. That is such an overgeneralization. It is true that we do have two sides of the brain, and it is true that they deal with information in slightly different ways, some parts of those sides of the brain, and they also react differently to them. But to argue that a poet is a right brain person and that's all, or a mathematician is a left brain person, is crazy. The two hemispheres communicate with each other all the time. And so killing this illusion idea is just, as I say, one more nail in the coffin. That's it for Jay's Journal.
In the years since the earthquake hit Haiti, there have been a lot of secondary disasters there. Crime, homelessness, and cholera, to name a few. The people of Haiti have been dealing with one nightmare after another. But one issue has been dogging the island for years, and it's landslides. Most of the hillsides in the country have been stripped of trees, and heavy rains therefore turn those mountainsides into landslide-prone areas. It's very similar to what happens in California, where wildfires have stripped the hills all above Los Angeles. So we caught up with a couple of geologists putting sensors into those hills in order to predict the next big landslide.
Jason and Dennis are gearing up for a hike in the hills above LA.
Maybe concrete and conduit.
Dennis has a bag of concrete.
Can the batteries go in there?
They could, but I'm a little worried they're gonna bang.
Jason, a radio transmitter and some scaffolding.
This is downhill.
It's a lot of gear because there's a lot of work to do.
Yeah, they can go.
And it starts with a long hike.
It's probably about a 10-minute walk.
10 minutes? Maybe if you're a mountain goat. More like 4 kilometers down scree-covered hills where every step is a treacherous one. 6 weeks ago, this hillside was on fire.
The station fire, I think it was early September.
Firefighters saved the nearby houses, but huge tracts of wilderness were devoured by the flames.
It burned 160 square miles.
Once the fire was out, people returned to their homes, unaware that another deadly threat is lurking in the scorched hillsides.
The wildfire creates changes in the soils and in the slopes themselves that can trigger landslides or debris flows.
The vegetation is destroyed and the topsoil has turned to ash.
This layer of ash on top will want to allow the water to infiltrate pretty rapidly. So if you just pour a little bit of water on top, it soaks in there pretty quickly, you can see. And so during a rainstorm, when it first starts raining, the water's going to come down and it's going to infiltrate into the ash layer on top. But if you scrape away just a few centimeters of material here, and you get down to the actual soil, it's not going to want to infiltrate as rapidly. You can actually see how it just balls up completely. What that causes is that this layer here, this top centimeter or so, will become saturated with water.
Waterlogged soil on a steep hillside is a deadly combination.
What we're here for is to try to understand how the process begins, starting with the way the rain falls onto the surface, all the way as you move down the slope, how it entrains material and how it flows down the channel.
Eventually, all the debris from the slopes will end up down in the valley.
Oh, nice. Okay, that's good.
So that's where the pair of scientists from the U.S. Geological Survey are setting up their monitoring station. The scaffolding bridge has to span the channel.
This would be
That's a
good
great spot.
because there's that rock.
Okay, so I'll go up here.
And be secure enough to withstand any really big slides.
I'll just dig a little more and call it good.
Okay.
That's where the concrete comes in.
If it does get whacked, I don't even know how much this concrete or even the fence posts are really going to help. As long as we can get some data leading up to the event, we'd be happy.
Below the bridge, they bury a pressure sensor.
We're trying to get down to bedrock so that we can set our pressure transducer in a stable configuration so that hopefully the debris flow would just run over the pressure transducer that's entrenched in the bedrock without actually ripping the pressure transducer out.
It's a lot of delicate equipment being put in a volatile place, but there's a very good reason for it.
There's really not a heck of a lot of measurements of these things. Exactly when during the rainstorm they come. There's not a lot of instrumentation out there that nails that down. And for the fire setting, there's even less. We know if it rains so much, there's going to be debris flow. But a lot of the database is yes, there was a debris flow, but there's no timing on it.
That timing will come from a radar unit hung over the channel,
So it'll measure how deep the flow is.
giving detailed information of when and how much debris is moving.
So as long as we've got this up high enough, doesn't get whacked, we're good.
The valley where the instruments are being placed is one of the few areas that still has tree cover. That's actually bad news for Jason and Dennis, because it means they have to climb partway up the other side of the valley.
The box we're going to do right now is the computer that's going to, or the data logger that's going to run the instruments down in the channel. And it's got to be up here for two reasons. One, it's got to have a rain gauge. And so we want the rain gauge to be like most of the basin without trees above it. It's also the powerhouse with solar panels, so it's going to have clear shot. And then it's got to see the cell phone relay up higher.
More pounding
That's probably good.
and more concrete,
I think I'm going to use a lot of concrete on this. This seems like it's going to go downhill.
leaving one last job for today.
This is a soil moisture probe. So it measures how much water's in the soil. And that's kind of important. Like if it's already wet from one storm and then another storm comes, you could have a different behavior.
All the information makes its way to the USGS website, where you'll find exact details of when and how much rain falls, what happens to the soil, and ultimately, how much Earth moves. That data will form the basis for future predictions. Sensors, relay stations, and probes, similar recording stations have to be set up throughout the region. It means many days of grueling labor for two men. There are a lot of people who live in the valley who are counting on them.
The 11 million people just down the hill, that's primarily why we're here.
And if a landslide does develop, Jason and Dennis will be the first to know about it.
Are you wondering where your tan went? Weird Planet gives you another reason why you should eat your veggies if you want to have a nice sunny glow. That's next.